Chapter 7, Problem 20. A block is sent up a frictionless ramp along with an x-axis extended upward. Figure gives the kinetic energy of the block as a function of position x. The scale of the figure vertical axis is set at Ks as 40 joules. If the block's initial speed is 4 meters per second, what is the normal force on the block? Well, let's just draw us a free body diagram. We have our block. We have gravity, mg, straight down. We have our normal. And we have, and the block is being pushed in this direction, not push. It just has an initial velocity of 4 meters per second. And it's going to go up to a height where it has 40.0 joules of energy at this height. So our normal force, N, minus mg cosine theta, that's what this side is. It's mg cosine theta equals ma times the acceleration. We know the block is not going to jump off of the incline, so the acceleration is 0. So N is equal to mg cosine theta. We don't know theta, and we don't have any idea at the moment what m is. But we do know that this is a conservative system. So we can say 40 joules where the block sits at this point at the height of the incline is equal to mgh, which is also equivalent to 1/2 mv squared. Now, we can find theta. That's what the first thing we're going to do. We're going to find theta, and also we're going to find the height. We already know that this length here is 2 meters. So, we can find the height, we can find theta. So let's go for the height first. So mgh is equal to 1/2 mv squared. M's will cancel. So this will go to h equal, so h is going to equal 0.5 times 4.0 meters per second squared over 9.8 meters per second squared, and this is going to equal to 0.81 meters. So that's the height of this incline. So we can say theta is equal to tan to the -1 of 0.81 2.81 divided by 2, the length of the base, 2.0, and that's going to equal to 22.0 degrees. So we know what theta is equal to. Now we need to figure out the mass. And we can plug this into our normal formula. So we go back here, and we can use either one of these to figure out the mass. So we'll just say mgh is equal to 40 joules, which goes to m, the mass, is going to equal to 40 joules divided by G times H. Should have just finished it off there, but 40 joules divided by 9.8 times 0.81, and that's going to equal 5 kilograms. So we know now what the mass weighs. Now we'll go to our original formula we got from doing our free body diagram, which is N. So we have N minus mg, N is equal to mg cosine theta, which is equal to 5 kilograms times 9.8 times cosine of 22 degrees, and that's going to equal 45 newtons. So we simply did a free body diagram. We use our associations, or we use from conservative, knowing that these are all a conservative system. We know that 40 joules is equal to mgh, which is the potential energy, which is equal to the kinetic energy. And we use this formula to get the mass and also to get theta that we needed. And then we just plugged it into our normal formula, which is 45 newtons.